London, 1928. St. Mary's Hospital. The lab stank. Not the clean antiseptic smell you'd expect from a place that was supposed to be sterile. No, this was different, musty, organic, like a basement that nobody had opened in years. Alexander Fleming didn't notice anymore. He'd gotten used to it. If you'd walked into his laboratory that summer, your first thought wouldn't be brilliant scientist at work. It would be, how has this place not been condemned? Petri dishes everywhere, stacked on counters, balanced on shelves, some so old that whatever was growing in them had probably evolved into new life forms. Glass tubes and flasks scattered across every surface, papers piled in chaotic mountains, the kind of mess that would give a modern lab inspector a stroke. Fleming's colleagues would walk past his door and shake their heads. Some would make jokes, others would just sigh. How does he find anything in there? Good question. Maybe he didn't. Maybe he just kept making new messes until something useful turned up. But here's what they didn't understand. Fleming wasn't careless, not really. He was just selective about what he paid attention to. Details about organization, cleaning, proper storage, those didn't matter to him. What mattered was the work, the bacteria, the invisible killers that had been slaughtering humans since the dawn of time. Fleming was obsessed with them. He'd seen what they could do, up close, personal, during the Great War, World War I, though nobody called it that yet because they didn't know there'd be a second one. Fleming had served as a military doctor, worked in field hospitals in France, saw things that still haunted him a decade later. Young men, teenagers, some of them, boys who'd survived bullets and artillery shells, who'd made it through the chaos of battle, only to die slowly, painfully, from infections. A simple wound would get infected, the infection would spread, turn into gangrene or blood poisoning, and then you'd watch them die. There was nothing you could do, nothing. You could clean the wound, amputate if it was a limb, pray. That was it. That was all medicine had to offer. More soldiers died from infected wounds than from the actual fighting. Think about that. Survive the war, still die anyway. It was cruel, senseless, wrong. Fleming swore he'd find a better way, some way to kill bacteria without killing the patient. 10 years later, he was still trying, still failing mostly. Dead ends, false starts, theories that looked promising and went nowhere. But he kept going, stubborn, relentless, maybe a little crazy. August 1928 rolled around, hot, sticky, the kind of weather that made London feel like a sauna. Fleming decided he needed a vacation, a break, time away from the lab and the failures and the frustration. He didn't bother cleaning up before he left. Why would he? He'd just pick up where he left off when he got back. The mess would still be there. It always was. So he walked out, left everything exactly as it was. Petri dishes sitting on the bench. Some of them had bacterial cultures growing in them. Staphylococcus, nasty stuff that caused infections. The windows were open because of the heat. No air conditioning in 1928. You either roasted or you opened the windows and let in the London air. Fleming left, went on vacation, probably didn't think about the lab at all. Meanwhile, back in that disaster of a workspace, something was happening. Spores were drifting in through the open windows. Fungal spores, mold, the kind of thing that's floating around everywhere, all the time, usually invisible, usually harmless. One of those spores landed in one of Fleming's Petri dishes. Pure chance, random luck, could have landed anywhere, could have landed nowhere near the lab, but it landed right there, in a dish that had Staphylococcus bacteria growing in it. And then it started to grow. Fleming came back in early September, tanned, rested, ready to get back to work. He looked at his lab and groaned. The mess had gotten worse.
The Petri dishes that had been sitting there for weeks were contaminated. Most of them were useless now. He started cleaning up, finally, going through the dishes one by one, checking what could be saved. Not much. He'd stack the ruined dishes in a tray of disinfectant, kill everything, start fresh. That's when he picked up one particular dish. Contaminated, obviously. There was mold growing in it, fuzzy, blue-green, the color of old bread left too long in a cupboard. He almost tossed it. Almost. But something made him pause, look closer. Around the mold, there was this clear zone, a ring of empty space, clean, transparent. And in that zone, no bacteria, none at all. The staphylococcus that had been growing in the dish, it was gone, just disappeared. Only near the mold, though. Further away, the bacteria were fine, growing normally, dense golden yellow colonies. But near the mold, nothing. Fleming stared. His brain started working, analyzing, questioning. This wasn't normal. Mold contamination happened all the time, annoying but common. But mold that killed bacteria, that created a perfect circle of death around itself, that was different. That was interesting.
He called over a colleague. A guy named Craddock happened to be in the lab. "Look at this," Fleming said. Craddock looked, shrugged. "Contaminated. Bad luck." Fleming shook his head. "No, look at what's happening around the mold." Craddock looked again, closer this time. The bacteria are dead." "Exactly." They both stared at the dish. Two scientists looking at what might be nothing, or might be everything. Fleming set the dish aside, carefully, gently. He wasn't going to throw this one away, not yet. Something was happening here, something he didn't understand, and in science, when you don't understand something, you investigate. The days that followed were a blur of activity. Fleming started running tests, trying to identify the mold. Turned out it was a type called Penicillin, common as dirt, grows on fruit and bread. Nothing exotic, nothing special, except it was killing bacteria. He grew more of the mold, tested it against different types of bacteria, Staphylococcus, Streptococcus, other dangerous pathogens. It worked, every time. The mold produced something, some kind of chemical substance, and that substance was lethal to bacteria. Fleming started calling it mold juice in his notes, not very scientific, but accurate. Later, he'd come up with a better name, Penicillin, named after the mold. But naming it was the easy part. The hard part was figuring out what to do with it. Fleming could grow the mold. He could see it killing bacteria in a Petri dish. That was great, fascinating, scientifically interesting. But it was useless, because he couldn't purify it, couldn't extract the active ingredient, couldn't turn it into something you could actually give to a patient. The mold juice was weak, unstable. It would break down in hours, sometimes minutes. And Fleming wasn't a chemist. He didn't have the skills or the resources to solve the purification problem. He tried. God knows he tried. Worked with other scientists, ran experiment after experiment, got nowhere. The medical community wasn't interested. Fleming published a paper about his discovery in 1929. Barely anyone read it. The few who did thought it was mildly interesting, a neat observation, but not practical. "Thanks, Fleming. Nice work. Let us know if you actually make something useful." That was the response. Polite dismissal. Fleming kept the mold alive, kept doing small experiments, but he couldn't crack the big problem. Years went by.
The mold sat in his lab, growing, waiting, and people kept dying every single day from infections that this mold could cure, if only someone could figure out how to use it. Fleming knew what he had. He knew the potential, and he was powerless to make it real. It was torture. But he didn't give up, didn't throw out the mold, didn't abandon the research, because deep down he believed. He knew this mattered, knew it was important.
Someday, someone would figure it out. Someday, this accidental discovery would save lives. He just had to keep it alive until that day came. Fleming stood in his messy lab on that September day in 1928, holding a contaminated Petri dish. He had no idea he was holding the future of medicine in his hands. No idea that this fuzzy blue-green mold would eventually save hundreds of millions of lives. No idea that this accident, this random spore floating through an open window, would change human history. All he knew was that something weird was happening, something worth investigating. So he investigated. That's the real miracle, not the mold itself, not the random chance of contamination. The miracle was that Fleming noticed, paid attention, asked questions. Most people would have thrown that dish away without a second thought. Contaminated culture? Toss it, start over. Fleming looked closer.
And in that moment, that simple decision to investigate instead of discard, the world changed. He didn't know it yet, wouldn't know for years, wouldn't live to see the full impact of what he'd found. But on that day, in that messy, chaotic, disorganized laboratory, Alexander Fleming stumbled onto one of the most important discoveries in human history, all because he was too messy to clean up before vacation, all because a mold spore drifted through an open window, all because he bothered to look. Sometimes that's all it takes, one person, one moment, one decision to pay attention. The rest is just waiting to see what happens next, and what happened next would change everything. Fleming couldn't sleep. It was late, past midnight. He should have been home hours ago, but he was still at the lab, staring at that Petri dish under the light. The mold sat there like it was mocking him, fuzzy, innocent-looking, just sitting there doing absolutely nothing. Except it was doing something, something impossible. It was killing bacteria without even touching them. Fleming had seen a lot of weird things in his career. Bacteria that changed colors, cultures that grew in strange patterns, contaminations that ruined weeks of work. But this was different. He'd spent the last 3 days running the same test over and over, growing Staphylococcus bacteria in fresh Petri dishes, adding a piece of the mold, waiting. Every single time, same result. The bacteria would start growing, spreading across the agar gel, doing what bacteria do. Then they'd hit that invisible wall around the mold and die. Not slow down, not grow differently. Die. Just stopped, like someone had drawn a circle around the mold and declared, bacteria cannot cross this line. It was the most beautiful thing Fleming had ever seen. And the most frustrating, because he had no idea how it worked, no idea what the mold was doing, no idea if this was just some weird quirk or something genuinely important. He needed to know. First question, what kind of mold is this? Fleming wasn't a mold expert. Bacteria? Sure. He could identify bacterial species in his sleep, but fungi? That wasn't his specialty. He went downstairs, found Charles Latouche, the mycologist who worked in the building. Need your help, Fleming said, holding out a sample. Latouche looked at it under a microscope, checked the spore structure, the branching patterns, the way it grew. Penicillium, he said after a few minutes. Penicillium notatum specifically. Fleming nodded. He'd heard of it. Common mold. Grew on citrus fruits, bread, basically anywhere organic material was decomposing. You could find it in any house in London, probably in every house in the world. Nothing special, nothing rare, just ordinary mold that apparently had superpowers. Thanks, Fleming said, taking back the sample. Latouche shrugged. Contamination happens. Just toss it and start fresh. Fleming didn't respond, just walked back upstairs to his lab. He wasn't tossing anything. Second question, does it work on other bacteria? Fleming had access to cultures of pretty much every dangerous bacteria known to medicine. That was his job, studying the things that killed people. He started testing, methodically, scientifically. Streptococcus, the bacteria that caused strep throat, scarlet fever, rheumatic fever. Grew it in a dish, added the mold, waited. Dead. The Streptococcus died. Diphtheria bacteria,
The stuff that killed children, closed their throats, suffocated them. Dead. Gonococcus caused gonorrhea, a sexually transmitted disease that was incurable, ruined lives. Dead. One after another. The major killers, the bacteria that filled hospitals and graveyards, all of them vulnerable to this mold. Fleming's hands were shaking as he recorded the results. He tried to stay calm, stay scientific, don't jump to conclusions. But inside, he was screaming. This could be it, the thing he'd been searching for, a way to kill bacteria without harming human tissue, the Holy Grail. Doctors had chemicals that could kill bacteria, plenty of them. Carbolic acid, mercury compounds, all kinds of harsh substances. But they killed everything, bacteria and human cells. You couldn't use them inside a living person. You'd kill the patient. What medicine needed was something selective, something smart, something that could tell the difference between bacteria and human tissue. Nobody had found it, not in all of human history, until maybe now. Fleming designed a new experiment, more complex, more ambitious. He grew the mold in liquid broth, let it sit for days. The mold spread across the surface, forming a thick mat. Then he did something clever. He filtered out all the solid pieces, removed every bit of the mold itself. What was left was just liquid, clear, slightly yellowish, looked like weak tea. He took that liquid and added it to a fresh Petri dish with bacteria, held his breath, waited. The bacteria died. Fleming sat down hard, felt dizzy. The mold didn't have to be there. It had released something into the liquid, some chemical compound, and that compound, all by itself, was killing bacteria. This was huge, massive, because if it was a chemical compound, you could potentially isolate it, purify it, turn it into medicine. Fleming started calling it mold juice in his notes. Unprofessional, maybe, but accurate. He needed a better name, something scientific. Penicillin, from penicillium. Simple, clean. He started running more tests, pushed the limits. He diluted the penicillin, 1 part penicillin to 10 parts water. Still worked. 1 part to 100, still worked. 1 part to 500, still worked. 1 part to 800, still killing bacteria. The stuff was incredibly potent. A tiny amount could wipe out massive colonies of bacteria. That was promising. That meant you wouldn't need huge quantities to treat an infection, maybe. Third question, would it hurt humans? Fleming tested penicillin on human blood cells, put them in a dish, added the penicillin, watched under a microscope.
The blood cells were fine, completely unaffected. He tried white blood cells, the immune cells that fight infection. Also fine, healthy, happy. He tested it on other human tissues. Same result, no damage. Penicillin killed bacteria, but left human cells alone. Perfect, exactly what he'd hoped for. But there was a catch. There's always a catch. These were cells in a dish, controlled laboratory conditions, sterile, simple. The human body is different, complex, messy, full of variables. Would penicillin work inside a living person? Would it reach the infection? Would the body break it down before it could work? Would there be side effects? No way to know without testing it on actual humans. And Fleming didn't have nearly enough penicillin for that, not even close, because there was a problem, a big, frustrating, seemingly impossible problem. The penicillin was unstable. It would break down, fall apart, stop working. Sometimes after a few days, sometimes after a few hours, sometimes faster. Fleming would make a batch of penicillin broth, test it, it would work great, come back the next day, test it again, weaker, much weaker. Wait another day, barely working at all.
The penicillin molecule, whatever it was, whatever its structure, was fragile, delicate. It would degrade on its own. Heat destroyed it. Cold destroyed it. The wrong pH destroyed it. Looking at it wrong destroyed it. Okay, that last part wasn't true, but it felt true. Fleming tried everything, different storage conditions, different containers, different temperatures. Nothing worked. The penicillin always broke down. And then there was the concentration problem. The broth that Fleming could produce, even at its best, was weak, really weak. To treat a human infection, you'd need gallons of the stuff, dozens of gallons, maybe hundreds, and it would start breaking down before you could even use it all. Fleming wasn't a chemist. He knew bacteria, knew biology, but chemistry? That wasn't his strength. He needed help, professional help. He reached out to Harold Raistrick, a biochemist, smart guy. If anyone could purify penicillin, it should be him. They worked together for months, trying everything, different extraction methods, different solvents, different purification techniques. Nothing worked. Every time they tried to concentrate the penicillin, it would degrade, fall apart, turn into useless sludge. After months of failure, Raistrick gave up, moved on to other projects. Fleming understood. He wasn't happy, but he understood. Why waste your career on something that might be impossible? Fleming wrote up his findings, put together a research paper, laid out everything he'd discovered. The mold, the bacteria it killed, the potential applications, the problems he couldn't solve. He tried to be hopeful, optimistic, but realistic. He submitted the paper to the British Journal of Experimental Pathology in 1929. It was published in June. Fleming waited for the response, the flood of interest, other scientists jumping on this research, helping solve the problems. Nothing. A few people read the paper, thought it was interesting, moved on. No follow-up studies, no collaboration offers, no excitement. The scientific community looked at Fleming's work and basically shrugged. Nice observation, Fleming, but not very practical. Let us know if you make any progress. Fleming gave presentations, tried to drum up interest. He wasn't good at public speaking, shy, awkward. He'd show his results and somehow make them sound less impressive than they were. People would nod politely, say, "Fascinating," in that tone that means, "I'm bored," and move on.
It was crushing, demoralizing. Fleming knew what he had, knew the potential, could see the future where penicillin saved millions of lives, but he couldn't make anyone else see it, and he couldn't solve the purification problem on his own. So the penicillin project stalled, ground to a halt. Fleming kept the mold alive, kept growing it, used it for lab experiments and demonstrations, but the dream of turning it into practical medicine, that seemed impossible. Years went by. Fleming moved on to other projects. Life continued. But he never forgot, never threw out the mold, never stopped hoping. Late at night in his quiet lab, Fleming would sometimes take out that original Petri dish, the first one, the contaminated one from 1928. He'd preserved it, kept it as a reminder of that moment when he'd seen something impossible, something beautiful, a clear zone around a mold, bacteria dying without being touched. He discovered something incredible. He knew it in his bones. He just couldn't make it work. Not yet. Maybe not ever. But he kept hoping, kept the mold alive, kept believing that someday, somehow, someone would figure out what he couldn't. Someone would turn this accidental discovery into the miracle it was meant to be. Fleming's moment would come. He just had to wait a little longer. Just had to keep hoping. Just had to keep that mold alive. And he did. Because that's what heroes do. Even when nobody knows they're heroes yet. 10 years later. Fleming sat alone in his lab, holding a flask of penicillin broth up to the light. 10 years. A decade of his life.
Gone. And what did he have to show for it? This, a flask of weak, unstable liquid that would be useless in a few hours. He set it down, rubbed his eyes. He was tired, so damn tired. Outside, the world was changing, getting darker. Hitler was making speeches in Germany. Armies were mobilizing. You could feel it in the air. War was coming. Another war, bigger than the last one. And Fleming knew what that meant. He'd lived through World War I, seen the casualties, the infections, the deaths. It was going to happen again. Thousands of young men were going to die from infected wounds. And he had the cure sitting right here in his lab. Useless. Completely useless. The irony was killing him. 10 years. He'd kept the mold alive for 10 years, kept doing experiments, kept hoping someone would care. Nobody did. Oh, people would visit sometimes. Other scientists, students, visitors from other universities. Fleming would show them his penicillin demonstration. It was like a party trick now. He'd grow bacteria in a Petri dish, add the mold, watch the clear zone form. See, he'd say, it kills bacteria, doesn't harm human cells, could be a miracle drug. They'd nod, say, interesting, ask a few polite questions, then they'd leave, move on with their lives, forget all about it. Fleming would go back to his messy lab and his useless penicillin. The problem hadn't changed, not one bit, not in 10 years. Penicillin was unstable, too weak, impossible to purify. He'd tried everything, worked with different chemists, different extraction methods, different approaches. All failures, every single one. The penicillin molecule was too fragile. It would fall apart if you tried to concentrate it. Heat destroyed it. Cold destroyed it. The wrong pH destroyed it. It was like trying to catch smoke with your bare hands. Harold Raistrick had given up back in 1929. Smart move, probably. Why waste years on something impossible? Other researchers had taken brief looks at penicillin over the years, read Fleming's paper, ran a few experiments, hit the same walls, moved on. Can't blame them. Everyone has their own career to think about, their own research, their own priorities. Why get stuck on an impossible problem? Fleming couldn't explain why he was stuck on it, couldn't explain why he wouldn't let it go. Maybe stubbornness, maybe guilt, maybe the memories of all those soldiers dying in World War I. Maybe he was just too proud to admit defeat. Whatever it was, he kept going, kept the mold cultures alive, kept running small experiments. For what? He didn't even know anymore. The medical community had moved on, forgotten about penicillin. His 1929 paper was buried in archives. Nobody cited it. Nobody referenced it. At conferences, if Fleming mentioned penicillin, people would smile politely, change the subject, talk about something more practical. It was humiliating. He'd discovered something incredible. He knew it, could prove it in a Petri dish. But knowing something works in a lab and making it work in the real world, those are different universes. Fleming had tried using crude penicillin on patients a few times, desperate situations. A man with a bad eye infection. Fleming applied penicillin directly to the eye. It worked. The infection cleared. The man kept his vision. That was promising, exciting. Fleming tried it again. Different patient, different infection. Didn't work that time. The infection got worse. The patient nearly died. Inconsistent, unreliable, not nearly good enough.
And those were surface infections, things you could treat by applying penicillin directly to the wound. What about internal infections, blood poisoning, pneumonia, the real killers? For those, you'd need to inject penicillin into the bloodstream, get it circulating through the whole body. But the crude penicillin broth was full of impurities. You couldn't inject it into someone. You'd probably kill them faster than the infection would. So Fleming was stuck. Absolutely, completely stuck. He'd found the treasure, but he couldn't dig it up, couldn't refine it, couldn't use it.
All he could do was sit there and watch people die from diseases he could cure. If only, if only, if only. Those two words haunted him. 1930 came and went. People died from pneumonia. More deaths, more funerals, more families destroyed. A young mother died from an infection after childbirth, left behind 3 kids. Fleming read about it in the paper, felt sick. Penicillin could have saved her. Probably. Maybe. He'd never know, because he couldn't make enough, couldn't make it stable, couldn't make it work. The years blurred together. Work, experiments, failures, repeat. Fleming kept teaching, kept running his lab, kept doing other research projects. But penicillin was always there in the back of his mind, the thing he couldn't solve, the failure he couldn't accept. His colleagues felt sorry for him. You could see it in their eyes. Poor Fleming. Brilliant man. Wasted a decade chasing an impossible dream. Some of them told him directly, "Alex, you should move on, focus on something more productive." He'd nod, smile. "Yeah, maybe you're right." Then he'd go back to his lab and grow more mold. Because what if they were wrong? What if penicillin wasn't impossible? What if he was just missing something, one key insight, one crucial technique? What if he gave up one day before the breakthrough? He couldn't risk it, couldn't let it go. So he kept working, alone, mostly ignored. The world moved on without him. There were other discoveries happening in medicine, other breakthroughs. Sulfa drugs came along in the mid-1930s, sulfanilamide and its relatives. They could treat some bacterial infections, not all, not even most, but some. It was progress, real progress. The medical community got excited. Finally, an antibacterial drug that actually worked in patients. Fleming tried to be happy about it, and he was, sort of. But sulfa drugs had problems, side effects, limited effectiveness. They didn't work on all bacteria. Penicillin would be better, so much better, if only he could make it work. If only.
Fleming turned 55, middle-aged, getting older. How much time did he have left? How many more years could he waste on this? He'd published occasional updates about penicillin, small papers, observations, nothing major. Nobody cared. The papers disappeared into the void of scientific literature. Fleming gave talks sometimes, tried to keep the dream alive. He demonstrated penicillin for a group of visiting scientists in 1937, set up a beautiful experiment, showed them everything. They were impressed, for about 5 minutes. Then someone asked, "Can you purify it?" Fleming shook his head. "Not yet, we're working on it." "Can you make enough to treat a person?" "Not yet." "Can you keep it stable?" "Not yet." Awkward silence, polite smiles. One of the visitors, a younger scientist, mid-30s maybe, spoke up. "Maybe it's just not possible," he said. "Not mean, just honest. Maybe some things work in a lab, but can't ever be practical medicine." Fleming wanted to argue, wanted to defend his work, wanted to explain that they were wrong. But what could he say? They weren't wrong, not really. He had no proof, no evidence, just belief, stubborn, irrational belief. "Maybe," Fleming said quietly, "maybe you're right." The visitors left. Fleming cleaned up the demonstration, put the penicillin cultures back on the shelf, sat down, put his head in his hands. Was he wasting his life? Should he give up, move on to something else? He thought about it, really thought about it. Then he looked at the mold cultures, growing quietly in their flasks, producing penicillin, doing what they'd been doing for 10 years. He couldn't quit, couldn't give up. Not because he thought he'd solve it, not because he believed in himself, because he'd seen too much death, too much suffering. Those soldiers in World War I dying from gangrene, blood poisoning, infected wounds. Their faces haunted him, young faces, scared faces. He'd failed them, couldn't save them.
if there was even a chance, even the smallest chance that penicillin could save the next generation, he had to keep trying, had to keep the mold alive, keep the research going, keep hoping. Even if it killed him, even if he wasted the rest of his life, even if he died a failure. At least he'd know he tried, gave it everything. That had to count for something. 10 years since the discovery. Fleming was older, grayer, more tired, but still working, still hoping, still believing when nobody else did. The clouds were gathering over Europe. War was coming. Everyone knew it. Hitler had annexed Austria, was eyeing Czechoslovakia, making demands, building armies. Britain was preparing, quietly, reluctantly. Nobody wanted another war. But it was coming anyway. You could feel it, inevitable, unstoppable. Fleming read the newspapers, watched the world sliding toward catastrophe, and knew that thousands were going to die, tens of thousands, maybe millions, many of them from infections, preventable infections. And he had the cure, right here, useless. It was torture, absolute torture. But what could he do? He'd tried everything, failed at everything. All he could do now was wait, hope, keep the mold alive. Maybe someone else would figure it out, someone smarter, someone with better resources, someone who could see what he couldn't. Maybe.
Fleming had to believe that, because if he didn't believe it, what was the point of anything? What was the point of discovering something incredible if it just sat on a shelf forever? There was no point, no meaning, just waste and failure and death. Fleming refused to accept that, so he kept working, kept hoping, kept that mold alive. 10 years of struggle, 10 years of failure, 10 years of watching people die when he could have saved them. But he wasn't done. Not yet. Not ever. Because somewhere out there, someone was going to read his paper. Someone was going to see the potential. Someone was going to have the skills and resources he lacked. Someone was going to finish what he started. Fleming just had to keep the flame alive until that person appeared. Just had to wait and hope and refuse to give up. Even when it hurt, even when it seemed hopeless, even when everyone else thought he was crazy. That's what heroes do. They hold the line. They keep believing. They refuse to quit. Even when nobody knows they're heroes. Even when they feel like failures. Fleming was failing, had been failing for 10 years. But he was still here, still trying, still hoping. And that hope, that stubborn, relentless, seemingly foolish hope, was about to pay off. He didn't know it yet, couldn't see it coming. But the cavalry was coming. Help was on the way. People who could do what he couldn't. People with the skills and resources and desperation to make penicillin work. Fleming's wait was almost over. His decade of struggle was about to end. The breakthrough was coming. And when it came, it would change everything. September 1st, 1939. German tanks rolled into Poland. Fleming heard the news on the radio, sat down hard in his chair, felt the room spin. It was happening. Again. 2 days later, Britain declared war. Prime Minister Chamberlain's voice crackled through speakers across the nation, somber, resigned, defeated before the first shot was even fired on British soil. This country is at war with Germany. Fleming turned off the radio, sat in silence. He'd known it was coming. Everyone had known. But knowing and experiencing are different things. War. Again. He was 58 years old, too old to serve this time, too old to work in field hospitals like he had in the last war, but not too old to remember. God, he remembered everything. The trenches, the mud, the screaming, the blood, and the infections. Always the infections. Watching young men survive bullets and shrapnel, only to die days later from gangrene, from blood poisoning, from pneumonia. Helpless, completely helpless to save them. That was 1914,
25 years ago. Medicine had improved since then. Better surgical techniques, better understanding of infection control, sulfa drugs that could treat some bacterial infections. But not enough, not nearly enough. This war was going to be different, bigger, faster, deadlier. Modern weapons, aerial bombardment, mechanized warfare, blitzkrieg. The casualties were going to be staggering. And Fleming still had nothing. 10 years of work, 10 years of hoping, and penicillin sat in his lab just as useless as ever. He felt sick, physically sick. How many were going to die? How many could he have saved if only he'd been smarter, better, if only he'd figured out the purification problem? The guilt was crushing. But there was nothing he could do, nothing except keep the mold alive and hope. Hope for what? A miracle? Yeah, exactly that. A miracle. Oxford University, September 1939. Two men were having a conversation that would change history. Howard Florey and Ernst Boris Chain. Florey was Australian, 41 years old, pathologist, serious, no nonsense, the kind of guy who showed up to work at 6 a.m. and didn't leave until midnight. He'd been studying how the body fought infections, trying to understand the immune system, looking for ways to help it work better. Chain was German-Jewish, 33, a refugee who'd fled the Nazis in 1933, brilliant biochemist, emotional, temperamental, prone to shouting matches and dramatic gestures. They shouldn't have worked well together, total opposites, but somehow they did. Chain had been digging through old research papers, looking for anything interesting about antibacterial substances, natural defenses, enzymes, anything that killed bacteria without harsh chemicals. That's when he found Fleming's 1929 paper, sat in the library reading it, read it twice, then a third time. This was interesting, really interesting. A mold that killed bacteria? A substance that was harmless to human cells but lethal to pathogens. Why hadn't anyone followed up on this? Chain took the paper to Florey's office, knocked on the door. "You need to read this," Chain said, practically vibrating with excitement. Florey took the paper, read it while Chain paced back and forth. Florey said when he finished. That's it? This could be huge." Chain set down the paper, thought for a moment. Could be, or could be nothing. Why didn't Fleming pursue it? Because he couldn't purify it, but we could. I could. Florey looked at Chain, saw the fire in his eyes. "Maybe," Florey said. "Worth investigating." They filed it away, kept it in mind, had other projects to finish first. Then the war started. Everything changed. Suddenly, the British government was pouring money into medical research, anything that could help the war effort, anything that could save soldiers' lives. Florey and Chain went back to Fleming's paper. This wasn't just interesting anymore. This was critical, essential, potentially war-winning. If they could make penicillin work, really work, not just in a lab, but as practical medicine, it could save thousands of Allied soldiers. Maybe tens of thousands. "We're doing this," Florey said. Chain grinned. "Hell yes, we are." They had advantages Fleming never had. First, money, real money, government funding, enough to hire a team, buy equipment, run serious experiments. Second, expertise. Chain was a world-class biochemist. If anyone could crack the purification problem, it was him. Third, urgency. The war created pressure, deadlines, a desperate need for results. And fourth, though nobody said it out loud, Chain had personal stakes. He was a Jewish refugee. If Britain fell to the Nazis, he was dead. Simple as that. Every other Jewish scientist he'd known in Germany was either dead, in a concentration camp, or scattered across the world. Chain had every reason to make this work. His life depended on it. His people's lives depended on it. He attacked the penicillin problem like a man possessed. Started growing massive batches of the penicillium mold, hundreds of flasks, The lab smelled like a moldy basement. Students complained. Chane didn't care. He extracted the crude penicillin broth. Then came the hard part, purification. Fleming had tried and failed. Raystrick had tried and failed. Everyone who touched this problem had failed. Chane tried anyway. Different solvents, different extraction methods, different purification techniques. Failed, failed, failed. The penicillin molecule was impossibly fragile. It would break down at the slightest provocation. Too much heat? Destroyed. Wrong pH? Destroyed. Wrong solvent? Destroyed. It was maddening, infuriating. Chane would work for 16 hours straight, make progress, then watch it all fall apart. He'd shout, throw things, storm out of the lab. Then come back and try again. Because giving up wasn't an option. Not for him. Not now. Florey kept the team focused, organized, moving forward even when it seemed hopeless. They worked around the clock, 12-hour days, 16-hour days. Sometimes they'd sleep in the lab. Months went by. 1939 turned into 1940. The war intensified. Germany conquered Poland, then Denmark, Norway, Belgium, the Netherlands. France fell in June 1940. The British Army barely escaped at Dunkirk. Britain stood alone. The Nazis controlled all of Europe. Invasion seemed inevitable. Any day now, German troops would land on British beaches. And if that happened, the penicillin project was over. Chane was dead. Florey probably too. The pressure was unbearable. Chane kept working, kept failing, kept trying. And then, finally, a breakthrough. He developed a technique using freeze-drying, freezing the penicillin broth, then evaporating the water in a vacuum.
What was left was a yellowish powder. Still not pure, still full of impurities, but more concentrated than anything Fleming had managed. Way more concentrated. They kept refining the process, making tiny improvements, adjusting temperatures, tweaking procedures. By mid-1940, they had something. Not perfect, not pure, but good enough. Good enough to test. Florey designed the experiment. 8 laboratory mice infected with lethal doses of Streptococcus bacteria, enough to kill them within hours. 4 mice got penicillin injections. 4 got nothing. The team gathered around to watch, tense, silent, waiting. The 4 untreated mice died, all of them, quickly, painfully. The 4 treated mice survived, all of them, completely healthy. 100% survival versus 0%. Florey stared at the results, hardly breathing. Chane started laughing, then crying, then laughing again. They'd done it. Penicillin worked in living animals, not just Petri dishes anymore. This was real. They published their results in The Lancet in August 1940. The response was immediate, explosive. This was what everyone had been waiting for, a genuine miracle drug. Florey read the paper in his lab at St. Mary's, sat down, read it again. They'd done it. Florey and Chane had solved the problem he couldn't solve. He felt relief, vindication, joy, and maybe a little sadness that it hadn't been him. But mostly relief, because this meant penicillin was real, going to happen, going to save lives. His decade of struggle hadn't been for nothing. Florey and Chane weren't done. Mice experiments were great, but mice weren't people. They needed human trials, needed to prove penicillin worked in actual patients. The problem? They didn't have enough. Growing and purifying penicillin was slow, difficult, labor-intensive. They could barely make enough to treat mice. To treat humans, they'd need massive quantities. The Oxford team scrambled, converted every available container into a penicillin production vessel. Flasks, bottles, baking pans, bedpans, literally hospital bedpans. They were growing life-saving medicine in bedpans because they didn't have proper equipment. It was ridiculous, desperate, embarrassing. And it worked.
By early 1941, they had enough penicillin to try treating one human patient, Albert Alexander, police constable, 43 years old. He'd scratched his face on a rose thorn while gardening. Just a tiny scratch, nothing serious, except it got infected. The infection spread. Abscesses formed on his face and scalp, entered his bloodstream. He was dying, slowly, horribly. Doctors at Radcliffe Infirmary had tried everything, sulfa drugs, surgery. Nothing worked. He had days left, hours maybe. Florey asked permission to try penicillin. Experimental, unproven. But what do they have to lose? The analysts agreed. February 12, 1941, first injection. 24 hours later, the improvement was dramatic, visible, miraculous. Alexander's fever dropped. The infection started clearing. He was eating, talking, smiling. Penicillin was working in a human being. The Oxford team was ecstatic. This was it, the proof they needed. But there was a problem, a horrible, crushing problem. They were running out of penicillin. They'd used almost their entire supply. They were even recycling penicillin from Alexander's urine, trying to extract every molecule. It wasn't enough. After 5 days, the penicillin ran out. Alexander relapsed. The infection came roaring back. He died on March 15, 1941. The team was devastated, heartbroken. They'd proven penicillin worked. They'd saved him, briefly, then watched him die because they didn't have enough medicine. Florey sat in his office, head in his hands, crying. Chains smashed glassware, screamed in frustration. They'd been so close, so damn close. But they learned something crucial. Penicillin worked in humans, definitively, no question. They just needed more, way more. Industrial-scale production, mass manufacturing. Britain didn't have the capacity. The country was under siege. Factories were building planes and tanks and ammunition. Nobody had resources for penicillin. Florey looked west, across the Atlantic, to America. The United States wasn't in the war yet. They had factories, resources, chemical companies. If anyone could mass-produce penicillin, it was the Americans. July 1941, Florey flew to the United States, brought samples of penicillium mold with him, smeared inside his coat lining. If the Germans had known what he was carrying, they would have done anything to stop him, because this mold was going to change the war. This mold was going to save thousands of Allied soldiers. This mold was a biological weapon disguised as medicine. Save your troops. Let the enemy die. Florey met with U.S. government officials, pharmaceutical companies, research labs, showed them what penicillin could do, explained the potential. There was interest, but not urgency. America wasn't at war yet. Then, December 7th, 1941 happened. Pearl Harbor. America entered the war, and everything changed.
Suddenly, penicillin wasn't interesting. It was critical, essential, a matter of national security. The U.S. government mobilized. The War Production Board got involved. Pharmaceutical companies stepped up. Pfizer, Merck, Squibb, Abbott. They were going to make penicillin, mountains of it, whatever it took, whatever it cost, because American soldiers were going to need it. And when American soldiers needed something, America delivered. The cavalry had arrived. Fleming's discovery, Florey and Chain's breakthrough, American industrial might, all coming together at exactly the right moment. The struggle years were over. The miracle was about to begin, and millions of lives were about to be saved. June 6, 1944. Dawn. The English Channel was black with ships, thousands of them, stretching to the horizon. Operation Overlord, D-Day, the largest amphibious invasion in human history. Inside the landing crafts, young men huddled together, wet, cold, terrified.
Most of them were teenagers, 18, 19, 20 years old, farm boys from Iowa, factory workers from Detroit, high school kids who'd never left their hometowns before. Now they were about to storm the beaches of Normandy, run straight into German machine guns and artillery. A lot of them were going to die. Everyone knew it. But the ones who survived the beach, the ones who made it past the bullets and explosions, they had something the soldiers of World War I never had. They had penicillin. Small vials of yellowish powder carried by every medic, every field hospital, every aid station behind the lines. A miracle in a bottle. Most of the soldiers didn't know what it was, didn't understand it, just knew that if you got shot, the medics would give you a shot of something that stopped infections. That's all they needed to know. The landing craft doors dropped. Soldiers poured out onto the beaches, into hell. The noise was unimaginable. Explosions, machine gun fire, men screaming. Bodies fell, blood mixed with seawater. The beach turned red. Private James Morrison from Ohio took shrapnel to his leg. Felt like someone had hit him with a baseball bat made of fire. He crawled behind a destroyed tank, bleeding, crying, sure he was going to die. A medic found him. Kid couldn't have been more than 20, hands shaking. "You're okay," the medic said, lying but trying to help. He bandaged the wound, then pulled out a syringe, filled it with penicillin from a small vial. "This is going to hurt," the medic said. Jabbed the needle into Morrison's arm, pushed the plunger. Morrison barely felt it. The pain in his leg was too intense. "What was that?" Morrison asked. "Penicillin keeps the wound from getting infected." Morrison didn't understand, didn't care, just wanted to stop bleeding. The medic moved on. Dozens more wounded soldiers needed help. Morrison was evacuated off the beach, taken to a field hospital, barely out of artillery range. The doctors worked like machines, triage, surgery, treatment, over and over. Morrison's wound was cleaned, surgically debrided, the shrapnel removed, then more penicillin, injections every few hours. In World War I, Morrison would have died. The wound would have gotten infected, gangrene would have set in, amputation maybe, or death. But this was 1944. 5 days later, Morrison was sitting up, eating, joking with the nurses. The wound was healing, clean, no infection, no fever. He'd live, he'd walk again, he'd go home to Ohio when the war was over. All because of penicillin. He was one of thousands, tens of thousands.
The story of how penicillin got to Normandy started 3 years earlier. December 1941. Pearl Harbor had just happened. America was in the war, and the U.S. government had a massive problem. They were about to send millions of young men into combat, and those men were going to get hurt. The Pentagon's medical planners knew the statistics. In World War I, for every soldier killed instantly, 3 more died later from infected wounds. 3 to 1. That ratio was unacceptable. The government threw money at the problem, serious money, unlimited resources. The pharmaceutical companies responded. This wasn't charity, this was business, profitable business. But it was also patriotic, a chance to save American lives, win the war. Pfizer, Merck, Squibb, Abbott, all the major drug companies, they committed to mass-producing penicillin, whatever it took. The problem was nobody had done this before. Penicillin had only been made in small laboratory batches. Growing it in massive industrial quantities, uncharted territory. The penicillium mold was temperamental, didn't grow well in large tanks, produced low yields. American scientists started a nationwide search for better mold strains. They called it the mold hunt, sent researchers everywhere, collecting samples from soil, rotting fruit, compost heaps, anywhere mold grew. Thousands of samples came back. Most were useless. Then a lab assistant in Peoria, Illinois, brought in a moldy cantaloupe from a local fruit market. Just a regular cantaloupe, overripe, fuzzy, would have been thrown in the trash. But the mold on it was different. Penicillium chrysogenum instead of Fleming's original notatum strain, and it produced penicillin like crazy, way more than the original. They worked with that strain, exposed it to X-rays and ultraviolet radiation, mutated it, selected the best producers, created super strains that produced 200 times more penicillin than Fleming's original mold. 200 times. The pharmaceutical companies scaled up, built enormous fermentation tanks, stories tall, thousands of gallons capacity, developed quality control processes, purification techniques, industrial chemistry on a scale never attempted before. It was expensive, difficult, required innovation at every step, but it worked. In 1943, American companies produced 21 billion units of penicillin. By 1944, 1.6 trillion units. The price dropped from essentially priceless to affordable, and it started reaching the troops. North Africa, 1943. American forces fighting in Tunisia. Desert warfare, brutal conditions, heat, sand, chaos. Lieutenant Chen took a bullet through the shoulder, clean through, missed the bone somehow. Lucky, except the bullet had been dirty, covered in sand and God knows what else. In World War I, Chen would have been in serious trouble. Even if the wound itself wasn't fatal, the infection would likely kill him. But this was 1943. The field surgeon cleaned the wound, removed debris, then injected penicillin directly into the tissue around the injury. "You're gonna be fine," the surgeon said. Chen didn't believe him. He'd heard stories from his grandfather about World War I, infections, amputations, death. But the surgeon was right. The wound healed. No infection, no fever, no complications. Chen was back with his unit in 3 weeks. He wrote home to his family, told them about the miracle drug, penicillin, saved his life. His letter was one of thousands, hundreds of thousands, soldiers writing home, telling their families about this incredible new medicine. Word spread fast. Penicillin, the wonder drug, the magic bullet. Newspapers started running stories. Miracle mold saves soldiers' lives. Fleming's name appeared in papers across America. The man who discovered penicillin. He was becoming famous, finally getting recognition after 15 years. But Fleming knew the truth. He'd discovered it, but Florey and Chain had made it work, and American industry had made it real. It took all of them, a chain of brilliance, a relay race of science, and now it was saving lives, thousands of lives. D-Day wasn't the first time penicillin proved its worth, but it was the biggest test. Over 150,000 Allied troops landed in Normandy on June 6, 1944. The casualties were enormous. Thousands wounded in the first few hours. Bullets, shrapnel, burns, crush injuries. Medics worked frantically, bandaging wounds, stopping bleeding, and administering penicillin. Every wounded soldier got penicillin, multiple doses. Doctors weren't taking chances. Field hospitals were set up just behind the front lines, barely safe, still within range of German artillery. The wounded poured in, dozens at a time, then hundreds. Doctors performed surgery after surgery, removing bullets, repairing damaged tissue, fighting to save lives, and penicillin backed them up, preventing infections before they could start. The survival rate was remarkable, unprecedented. In World War I, if you got seriously wounded, you had maybe a 50% chance of surviving. In World War II, with penicillin, 70%, 80%, sometimes higher. That difference was thousands of young men who went home instead of being buried in foreign soil. Private Morrison from Ohio, Lieutenant Chen from California, Corporal Davis from Georgia, Sergeant O'Brien from New York. All of them lived. All of them had wounds that would have killed them in the previous war. All of them were saved by a mold that Fleming had accidentally discovered in 1928. The military classified penicillin as a strategic resource, top priority.
Every bit of production went to the armed forces first: soldiers, sailors, Marines, airmen. Civilians in America couldn't get it, not yet. If you were a civilian with pneumonia in 1943, too bad. No penicillin for you. You got sulfa drugs if you were lucky, prayer if you weren't. But if you were a soldier with an infected wound, immediate treatment, best medicine available. It wasn't fair, but war isn't fair. The military's argument was simple. Healthy soldiers win wars. Win the war, everyone benefits. Hard to argue with that logic. And it worked. Penicillin gave the Allies a massive advantage. American and British soldiers survived wounds that would have killed them, stayed in the fight, kept fighting. German soldiers, they didn't have penicillin, not in any significant quantities. They had sulfa drugs, better than nothing, but not nearly as good as penicillin. German troops died from infections that Allied troops survived. That's a strategic advantage, a military edge. Some historians think penicillin shortened the war by months, maybe a year, saved Allied lives, ended the conflict faster. It's impossible to prove, but it's plausible.
The stories kept coming. Personal stories, miracles. A bomber pilot shot down over France, wounded, captured by the resistance. They smuggled him to a safe house. No doctor, no hospital, just a resistance fighter with a stolen vial of penicillin. The fighter had watched a medic use it once, remembered the procedure, injected the pilot, hoped for the best. It worked. The pilot survived, healed, eventually made it back to England. A sailor burned in a naval battle in the Pacific, third-degree burns across his chest and arms. Burns almost always got infected. The mortality rate was horrendous. But the ship's doctor had penicillin, used it aggressively, multiple injections per day. The sailor lived, scarred, yes, but alive. A paratrooper who landed in a tree on D-Day broke his leg, compound fracture, bone sticking through the skin. In any previous war, that meant amputation, best case scenario. Worst case, death from gangrene. But the medics had penicillin. They set the bone, injected penicillin around the wound, kept him on it for days. The leg healed. The paratrooper walked again, went home to his family after the war. On and on. Thousands of stories. Each one a life, a person, someone's son, brother, husband, father. Each one saved by penicillin. The war ended in 1945. Germany surrendered in May, Japan in August, and suddenly all that penicillin production didn't need to go to the military anymore. It could go to civilians, regular people, everyone. That's when penicillin truly became a miracle drug, because all those diseases that killed people in peacetime, now they were treatable. Pneumonia, before penicillin, major killer, especially of children and the elderly. After penicillin, curable, almost routine. Strep throat, scarlet fever, bacterial meningitis, syphilis, gonorrhea, infections from childbirth, post-surgical infections, infected wounds from accidents. All treatable, all survivable. Life expectancy jumped. In America, it went from about 63 years in 1940 to over 68 by 1950. Child mortality dropped dramatically. Mothers stopped dying from puerperal fever after childbirth. It's hard to overstate how big a change this was. Imagine living in a world where a simple infection could kill you, where pneumonia was often a death sentence, where surgery was incredibly risky because of post-operative infections. That was the world before penicillin. After penicillin, that world was gone forever. Parents didn't have to watch their children die from scarlet fever anymore. Young mothers didn't die from infections after giving birth. A cut on your hand didn't risk turning into blood poisoning. People called it a miracle, and they weren't wrong. Fleming watched all of this unfold, watched his accidental discovery transform medicine, save millions of lives. He gave interviews, speeches, tried to explain what had happened, but he always came back to the same point. It was an accident. He'd been lucky. Observant, yes, but mostly lucky. And he always warned about the future, about resistance. Bacteria will adapt, he said, over and over. If we misuse penicillin, it will stop working. People smiled and nodded, but they didn't really listen. Penicillin was too miraculous, too effective, hard to imagine it ever failing. Fleming knew better. He'd been studying bacteria his whole career, knew how evolution worked. But he was ignored, again. That seemed to be his fate, being right and being ignored. Still, he took satisfaction in what had been achieved, what penicillin had become. 15 years from a contaminated Petri dish to a world-changing miracle drug. 15 years of struggle, failure, persistence, breakthrough. His discovery, Florian Chain's chemistry, American industrial might, wartime urgency, all of it coming together at exactly the right moment to save millions of lives. Private Morrison went home to Ohio, married his high school sweetheart, had 3 kids, lived to be 82. Lieutenant Chen went back to California, became a teacher, taught history for 30 years, told his students about penicillin every year. The paratrooper with the broken leg became a carpenter, built houses, raised a family. The bomber pilot became a commercial airline pilot, flew for 40 years, never forgot the resistance fighter who saved his life with a stolen vial of medicine. Thousands of stories, millions eventually, all because Fleming noticed something strange on a contaminated Petri dish. All because Florian Chain refused to give up on an impossible problem. All because American factories mass-produced a miracle. All because thousands of medics and doctors and nurses used that miracle to save lives. That's the real story of penicillin. Not just one person, not just one moment. A chain of brilliance, persistence, courage, innovation. Stretched across 15 years, multiple countries, hundreds of thousands of people, all working towards the same goal, whether they knew it or not. To save lives, to reduce suffering, to give humanity a weapon against one of its oldest enemies, bacterial infection. And they won. Not completely, not permanently, but they won that battle, decisively, overwhelmingly. Penicillin changed the world, saved more lives than any general or politician or leader ever could, turned the impossible into routine, the miraculous into medicine. And it all started with mold on a Petri dish, a messy lab, an observant scientist, an accident that became a miracle. That's the power of science, the power of human ingenuity, the power of refusing to give up even when everyone says it's impossible. Fleming knew. Florian Chain knew. All those soldiers on D-Day knew. Sometimes miracles are real. Sometimes accidents change everything. Sometimes the world gets better. And sometimes, just sometimes, humanity wins. October 25, 1945. The telegram arrived at St. Mary's Hospital. In the morning, Fleming was in his lab when someone knocked on the door, one of the administrators, smiling, holding an envelope. She said, "This just came for you, from Sweden." Fleming took it. His hands were shaking slightly. He knew what it was before he even opened it. The Nobel Prize. He'd won the Nobel Prize in physiology or medicine, along with Howard Florey and Ernst Boris Chain. All 3 of them shared prize for penicillin. Fleming sat down, read the telegram again, then a 3rd time. 17 years from that contaminated Petri dish in 1928 to this moment. 17 years of work, struggle, doubt, hope. And now this, the highest honor in science. He should have felt ecstatic, triumphant, on top of the world. Instead, he felt tired, relieved, and strangely sad. Because he kept thinking about all the people who died, all those years when penicillin sat in his lab, useless. What if he'd been smarter, faster? What if he'd figured out the purification problem himself? How many more could he have saved? He knew that was irrational, unfair to himself. He'd done everything he could. But the guilt still gnawed at him. Still,
This was good. The Nobel Prize meant recognition, validation, proof that the work mattered. And maybe it would help get penicillin to more people, help fund more research, help save more lives. That's what mattered, not the glory, the lives. December 10th, 1945, Stockholm. The award ceremony was formal, elegant, kings and dignitaries in attendance. Fleming wore a tuxedo, felt uncomfortable. He'd never been good at fancy events. Give him a lab coat and a microscope and he was confident. Put him in formal wear at a royal ceremony and he felt like an imposter. Florey was there too, Chain, both in tuxedos, both looking as uncomfortable as Fleming felt. They'd barely spoken to each other. Polite nods, brief greetings, nothing more. There was tension, awkwardness, resentment maybe. Fleming got most of the public credit. The newspapers called him the man who discovered penicillin. Florey and Chain, they were footnotes, and two other scientists who helped. It wasn't fair, not really. Fleming found it, but Florey and Chain made it work. Without them, penicillin would still be sitting in a lab somewhere, useless. Florey resented the imbalance, Chain even more so. They'd done the hard work, the impossible chemistry, the clinical trials, the push towards mass production, and Fleming got the glory. Fleming knew it too, felt guilty about it, but what could he do? He couldn't control what the newspapers wrote. The ceremony began, speeches in Swedish, then English translations. The award was announced for the discovery of penicillin and its curative effect in various infectious diseases. Fleming's name first, then Florey, then Chain. They walked up together, accepted their medals and certificates, shook hands with the King of Sweden. Photographers flashed, the audience applauded. Three men who'd changed the world, standing together, smiling for the cameras, pretending they were friends. Fleming gave his Nobel lecture the next day.